When we hear the word salt, we tend to think of the edible white substance that is used to season food. This is, however, only one example of a salt, common table salt. The name of the salt is sodium chloride. A salt is an ionic compound produced by reacting an acid with a base, also known as a neutralization reaction, or they may be naturally occurring minerals. Salts may be classified in two ways. The first is to identify if the salt is normal or acidic. Remember, a salt is formed when a metal ion or cation replaces the proton from an acid. A normal salt is formed when all of the hydrogen ions have been replaced. Phosphoric acid has 3 protons, or we can say it is tribasic. If we react phosphoric acid with sodium hydroxide, the sodium ions will replace the hydrogen ions. If all 3 protons are replaced, the salt formed is said to be normal, and its formula would be Na3PO4. We know acids and bases react to form salt and water, so the other product is, of course, water. Acid salts are formed when only some of the protons are replaced. This means some hydrogen ions will remain. This is again a phosphoric acid which has 3 protons. When it reacts with sodium hydroxide, if only 1 proton is replaced, the formula would be NaH2PO4. We started with 3 protons but replaced only 1 with sodium. So the salt has 1 sodium ion and 2 hydrogen ions, NaH2PO4. Water would also be formed. If 2 protons are replaced by 2 sodium ions, the formula will be Na2HPO4. Since only 1 hydrogen remains. We can always tell which salts are normal and which are acidic by looking at their formula. Remember, an acid is a proton donor, so any salt which still has protons is an acid salt. Normal salts do not have protons. Acid salts react similarly to acids, so they can react with bases to form a salt and water, with carbonates to form a salt, water, and carbon dioxide, or with a metal to form a salt and hydrogen gas. To test if a salt is acidic, react it with a metal and test to see if hydrogen is produced, or with a carbonate and test to see if carbon dioxide is produced. Ionic compounds exist as crystal lattices. A crystal lattice is a regular repeating arrangement of the ions. From the particulate theory, we know that there are spaces between all particles, so there are spaces in crystal lattices. These spaces can hold water. This is called water of crystallization, and this is the second way we can classify salts. Salts may be anhydrous or hydrated. An anhydrous salt has no water in its lattice, or in other words, they have no water of crystallization. Examples include sodium chloride and calcium carbonate. Hydrated salts, on the other hand, do have water in their crystal lattice, represented by blue in this diagram. Hydrated salts have water represented in their formula. Hydrated copper sulfate has the formula CuSO4.5H2O. Preparing salts. In order to prepare a sample of a salt, you must know if the salt is soluble or insoluble. These are the solubility rules. A soluble salt is one which dissolves in water. Once the salt dissolves, it will separate into its ions. The soluble salts are nitrates, chlorides, and the sulfates, but there are a few exceptions. All chlorides are soluble except for silver chloride and lead chloride. All sulfates are soluble except for silver sulfate, lead sulfate, barium sulfate, and calcium sulfate. All nitrates and any salt containing lithium, sodium, potassium, or ammonium ions are soluble. Let's look at some examples. The examples of insoluble salts are phosphates and carbonates, magnesium carbonate, barium carbonate. Examples of insoluble salts are calcium phosphate, magnesium carbonate. Because they are insoluble, they do not separate into their ions, and calcium phosphate. Because they are insoluble, an exception they do not separate into their ions. Potassium phosphate, because any salt that contains sodium, potassium, lithium, or ammonium ions because are any salt that contains sodium, potassium, they will separate lithium or ammonium ions are soluble. Other insoluble substances are oxides and hydroxides in water. Study their exceptions as seen in your notes. Other insoluble substances are oxides and hydroxides. The salt tells exactly which ions are present in your notes. So be sure to again study the ions and the name of the salt tells exactly which ions are present. So be sure to again study the ions and their names. For salts that are soluble, there are 4 ways to prepare them. The first is by direct combination. For salts that are soluble, this is where there are 4 elements that make up the salts are simply the first is by direct combination. In this example, this is where of sodium elements that make up the salts are simply a piece of sodium metal is added to this example is of sodium chloride. The formula for the reaction: a piece of sodium metal is added to some chlorine gas. Sodium chloride. The formula for the reaction: an exception is potassium phosphate because any salt that contains sodium, potassium, lithium, or ammonium ions are soluble. They will separate into their ions when in water. Other insoluble substances are oxides and hydroxides. Study their exceptions as seen in your notes. The name of the salt tells exactly which ions are present, so be sure to again study the ions and their names. Let's move on to the preparation of salts. For salts that are soluble, there are 4 ways to prepare them. The first is by direct combination. This is where the elements that make up the salts are simply reacted with each other. This example is of sodium chloride, where a piece of sodium metal is added to some chlorine gas. The formula for the reaction: sodium plus chlorine to form sodium chloride. This isn't an ideal method because chlorine gas is poisonous, sodium metal is highly reactive, and explosions occur when it reacts with air or water. It's also evident that the reaction here is explosive as well. The other three methods are based on the reactions of acids, which we have covered. A salt can be prepared by reacting an acid with a metal. The acid chosen must have the appropriate anion, and the metal must be one to produce the appropriate cation. If we wished to prepare magnesium chloride, the metal must be magnesium, and the acid must be hydrochloric acid since it will give chloride ions. The metal is added to the acid. We know this produces a salt and hydrogen gas, so the mixture will fizz as seen. The fizzing stops when all the acid has reacted. Since metals can't be dissolved, the mixture is then filtered to remove the excess metal left from the reaction. The mixture is heated to remove some of the water by evaporation, leaving a concentrated salt solution which will crystallize, giving us our salt sample. We could also have a reaction between an insoluble carbonate and an acid to create a salt. Again, a suitable acid is used to provide the anion we require. The carbonate must possess the appropriate cation. To prepare magnesium sulfate, since the cation is magnesium, the carbonate must be magnesium carbonate. The acid must be sulfuric acid since it contains the sulfate ion. When we add the carbonate to the acid, again we would see fizzing because carbon dioxide gas is produced. The mixture would stop fizzing as soon as all the acid has reacted. Because we use an insoluble carbonate, it can be filtered, giving us a filtrate of the salt and water only. Again, we would evaporate some of the water, leaving a concentrated salt solution in order for the salt to crystallize. Preparing insoluble salts. In order to prepare an insoluble salt, two solutions of soluble salts must be mixed together, which will result in a precipitate of the insoluble salt being formed. One solution will provide the cation, while the other provides the anion. Let's quickly recap which salts are soluble. The nitrates, chlorides, and the sulfates are soluble, with a few exceptions as shown. Any salt containing sodium, potassium, lithium, or ammonium ions is soluble. If we wish to make a sample of lead chloride, we need a soluble salt which contains lead. The salt could not be lead sulfate or lead chloride, as these are insoluble, but we see no exceptions for nitrates. So one of our reactants can be lead nitrate. These are the ions present. The other soluble salts must contain chloride ions. We can use any chloride except for those listed as exceptions in the table. Elements from group 1 and 2 of the periodic table can help us. We could use lithium chloride, beryllium chloride, sodium chloride, magnesium chloride, or potassium chloride. Let's use sodium chloride. These are the ions. Our reagents are lead nitrate and sodium chloride. Because these salts are soluble, they will separate into their ions when placed in water. Recall that particles are in constant motion and can collide, resulting in a chemical reaction. So, when lead and chloride ions collide, they will form the precipitate of the insoluble salt, a solid lead chloride. The other ions would form a soluble salt, sodium nitrate. The method to prepare insoluble salts is simply to 1. Add the two solutions together, and 2. Filter the precipitate, which is the insoluble salt. Our insoluble salt would be trapped in our filter paper, while the soluble salt would pass through in the filtrate. Please note the state symbols in the equation. AQ, aqueous, means dissolved in water and is used to signify the soluble salts. S means a solid and signifies the insoluble salt. After the reaction is complete, only the products would be present, since reactants would be used up. When the mixture is filtered, lead chloride would be in the filter paper, while a sodium nitrate solution will be the filtrate. Our second example is magnesium carbonate. We need 2 soluble salts, one with magnesium. As we can see, there are no exceptions which include magnesium, so we could use magnesium nitrate, magnesium chloride, or magnesium sulfate. Let's use magnesium sulfate. These are the ions present. Our second salt must have the carbonate ion. We should remember that carbonates are insoluble, but any salt that contains sodium, lithium, potassium, or ammonium ions is soluble. Let's use potassium carbonate, and these are the ions. Our reactants are magnesium sulfate and potassium carbonate. When dissolved, the ions will separate, but Magnesium and carbonate ions collide, forming the solid magnesium carbonate. Potassium sulfate is the second product. The final example is barium sulfate. The first soluble salt can be barium nitrate or barium chloride. Let's use barium chloride, and these are the ions. The second salt must have sulfate ions. We could use lithium sulfate, beryllium sulfate, sodium sulfate, magnesium sulfate, potassium sulfate, or ammonium sulfate. And let's use lithium sulfate. These are its ions. Our reactants are barium chloride and lithium sulfate. Collision of our two ions form barium sulfate or insoluble salt, and lithium chloride would be the other product. Please practice writing the formula of ionic compounds in order to write the correct formula of these salts. Also, practice balancing equations. You may notice that the equations in this video are not balanced.